Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the truth table, characteristic table, and excitation table of SR flip-flop. So, my students, in the last lecture, we had discussed the SR flip-flops working. The SR flip-flop is designed with a NAND gate, and the second set of NAND gate is the SR latch itself. And the truth table of SR flip-flop, as we mentioned in the last lecture, is the clock signal 0 results in a memory condition, and the clock signal with 1 results in 4 different conditions. That is, clock signal equal to 1 with S equal to 0, R is equal to 0 results in a memory condition. Clock equal to 1, S equal to 0, R equal to 1 results in a 0 condition. Clock equal to 1, S equal to 1, R equal to 0 results in a output of 1, and clock equal to 1, S equal to 1, R is equal to 1 is an invalid condition. So this last condition is not using in a SR flip-flop with an AND gate. So my dear students, so if we are expanding this truth table or detailing this truth table, the Qn represents the previous output and the Qn plus 1 represents the present output. So the truth table can be represented as clock equal to 0 and don't care conditions. That is, if the clock signal is 0, the output Qn plus 1, that is the present state, is the memory condition, that is the previous output Qn itself. Clock equal to 1 and S equal to 0, R is equal to results in a present state Qn plus 1 is equal to Qn, that is the previous state itself. So this will be the truth table of the SR flip-flop. Based upon this truth table, we are going to design a characteristic table of this SR flip-flop. So when it comes to the characteristic table, we are giving the inputs as Qn, S and R. So this three input or three variable results in the combination of 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. And now we are discussing what will be the present output, that is Qn plus 1's different value combination. So if we are starting with S equal to 0, R is equal to 0, according to the truth table, S equal to 0, R is equal to 0 results in a Qn plus 1 value with Qn itself, that is the memory condition is using here. So Qn plus 1 value will be the Qn value itself. That simply means that in the characteristics table, if S is equal to 0, R is equal to 0, results in the Qn plus 1 value is equal to Qn itself, that is Qn plus 1 will be 0 itself. If we are moving towards the second step, that is S is equal to 0, R is equal to 1, so according to the truth table, the Qn plus 1 will be 0, so we are writing it as 0. And if we are moving to the third table, that is S equal to 1, R is equal to 0, according to truth table, the output Qn plus 1 will be 1, so 1 is writing in Qn plus 1's characteristic table. So if we are moving to the 1, 1 condition, that is S is equal to 1, R is equal to 1, according to truth table, this condition is a invalid condition, so we are representing it as X, that is we are not using this condition. And if we are moving towards Qn is equal to 1 with S is equal to 0, R is equal to 0, so according to the truth table, S equal to 0, R is equal to 0 results in an output of Qn, that is previous state itself. So here the previous state is 1, therefore the present state Qn plus 1 will be 1 itself. If we are moving to 0, 1 condition, so according to truth table, 0, 1 results in an output of 0, so we are writing the Qn plus 1 characteristic as 0. And if we are moving to 1, 0 condition, according to truth table, 1, 0 results in an output of 1, thus we are writing it as 1. And if we are moving to the 1, 1 condition, then the output of Qn plus, then the output will be invalid, so we are marking it as invalid condition. So this is the characteristic table of SR flip-flop. So the characteristic table has three inputs, Qn, S and R, and the Qn plus 1 represents the present output and Qn represents the previous output, or Qn plus 1 represents the present state and Qn represents the previous state. So now we are moving towards the excitation table of this SR flip-flop. So this excitation table will be used in the flip-flops conversions as well as the digital counter designing circuits. So the excitation table is very much important in the concept of counters as well as flip-flop conversions. So if we are moving towards the excitation table, the input of excitation table is Qn and Qn plus 1. Thus we can tell that we are dealing with the two variables, and the combination of these two variables will be 0 0 0 1 1 0 and 1 1. And this excitation table is represented or designed with the help of this characteristic table. So the first case, that is Qn is equal to 0, Qn plus 1 equal to 0, that is a 0 0 condition, can be marked in the characteristic table as shown here. Qn is equal to 0 and Qn plus 1 equal to 0 can be shown as two different possibilities with S value equal to 0 and R value as 0 and 1. Here we can tell that the S value is 0 in both these conditions, thus we are marking the excitation table with S as 0, and the R value is changing to 0 as well as 1, thus we can mark it as X, that is, it is having different values. And if we are moving to the 0 1 condition, according to the characteristic table, the 0 1 condition results in S and R value as 1 and 0, and this can be marked in the excitation table. So now we are moving to the 1 0 condition. In the 1 0 condition, the characteristic table has one combination with the S value as 0 and 1, thus this value is marking in the excitation table. And if we are moving to the last condition, that is 1 1 condition, we can see two different combinations with the S value 0 and 1 and R value 0 itself. Thus the excitation table of 1 1 will be X0, that is don't care 0, that is the S value can be either 0 or 1 and the R value will be 0 itself. So my dear students, this is how we are representing the truth table, characteristic table and excitation table of SR flip-flop. So dear students, this characteristic table is designed with the help of a truth table, as well as the excitation table is designed with the help of a characteristic table. So truth table is very important in the case of a flip-flop. So dear students, hope you had understood this topic. So my dear students, kindly write down this assignment question. Assignment question is write notes on SR flip-flop. Basically, write notes on characteristic table, excitation table and truth table itself. So dear students, see you soon. In the upcoming lecture, we will discuss D flip-flop. So dear students, see you soon. Until then, goodbye, thank you and all the best.